My brother.
Professor Dario Leslie.
President International Biochemistry.
Thank you very much.
This is the DG here. Paul is the Vice President FASBMB.
Okay. Yeah.
Just another Paul again.
Oh, okay. Nice meeting you. Yeah. Yeah. Thank you.
Ladies and gentlemen, let me start first DG for this one. I appreciate you for this wonderful opportunity having us here at SHESTCO. In fact, we find it very delightful that you gave us this opportunity to use your complex. We were biochemists and we participated in almost all our activities. We felt we should come and also demonstrate some of our activities where you control. The DG sir, today you have members of the International Union of Biochemistry and Molecular Biology, Federation of African Scientists of Biochemistry and Molecular Biology, Nigerian Society of Chemistry and Molecular Biology. IUBMB is the father or mother of all these societies. And you have the president here today in person of Professor Dario Leslie. Professor Dario Leslie came all the way from UK, a long flight, but one thing I know about him is that he's passionate about research, particularly in biochemistry and molecular biology. In third world countries, he has been to so many countries. The last time he was in Kenya, today he's in Nigeria, and he's fascinated. Some things I heard about him, about Nigerian scientists, is indeed worthy of mention. He's here to see how he can support us. His presence here alone has activated us, and we're all looking forward to his speech.
You know, I think, I've never been to Nigeria before, but from what I've read and I've talked to many Nigerians, you have an incredibly wealthy nation, blessed with wonderful weather and minerals and huge, very large population of incredibly well-educated people, and all the work that you and your colleagues do at universities to train the best, the young people into very established and well-educated citizens is pretty incredible. And what we need to do now is to help you harness this huge potential. And then if you become one of the greatest countries in the world, you could just harness this and unlock the potential that you have locked in under your feet. And so this is what we need to do to help you, and it's a great privilege for me to be here and to come and meet you today. And I just want to learn how we can help, what we need to do, and how we can support you and other countries in Africa as well. And I think Africa in general is underrepresented in the world's table of science, life sciences certainly. We have Asia's doing very well, America's doing well, Europe's doing well, but we don't see enough African scientists at the major meetings of the work, in the major laboratories. And the other thing that worries me as well is when we have Africans who come to America or to Europe or to other labs, they often stay, they don't come back. And that's not helping anybody. I mean, yeah, we're getting a great deal in Europe, so we're getting fully educated scientists coming to our place, working very hard after they've been trained, and you've invested so much time and energy in them, and then they don't go back to your country. So we need to think about this as well, how we can help and without stealing from you, your best people. And I don't have the answers, I'm afraid, but I'm happy to talk and contribute to the discussion and help you and your scientists in every way. So I'm looking forward to this visit. Thank you very much.
Thank you very much. That was Professor Dario. Next person I'd like to call upon is the President, FASBMB person of Professor Babies. At one time, the president of NSBMB, he has managed to control and to activate and keep the fire of NSBMB burning. And with all that, he became the president of Federation of Biochemistry and MolecularBiology. And in his term, we have been able to, call the attention of IBMB, and they are here today. He has helped steer this association, and we're very proud of him. It may also be interesting to note that he's the freshest and youngest member of the Fellow of African Academy of Science. He has done so much for science. He's our father.
We're going to watch it.
Yes, we are. He's our father.
This is information.
And our mentor. He's a passionate researcher. He's somebody that meets you up in the lab by yourself. Yeah. To know what the result is all about.
Thank God that he's able to make it now. I remember we shifted this workshop simply to accommodate. He's a very, very, very busy man, and despite that, he makes time to come and share the wisdom with him. We started discussing this in Australia in 2003 in Melbourne. Possibly, yes. That's actually when we started discussing about this visit. And we thank God that he's here. My friend DG is somebody that I know since 93, 94. And since then we have been together. He's a passionate biochemist. We move around with him. Anytime you have been conference of biochemistry, even when we reactivated NSBMB with him, Professor Akanji, and a few others, and to what we are now. We look forward to this training workshop. It took time to plan for this, and despite this, he gave us the opportunity to use these facilities. I was telling Dario the wisdom behind these facilities is to bring researchers across the universities here and advanced upscaled your research to a commercial product. That's what SHEDA is meant about. So probably some of us will be seeing this facility for the first time, and I'm sure that DG will leave his door open for some of us to come back here and advance our research within their facilities. DG will sincerely appreciate this. May God. Thank you, my brothers and sisters.
Yesterday I had a good conversation with both him and the president of IBMB. In my opinion, I thought I love lab, but I met people, senior researchers that are indeed lab rats. So passionate about research that even when we came up with the teams for the workshop, he quickly jumped. Look, I'm going to buy you the IPG strip. I'll come with it with South Africa. And yesterday I handed it over to me. Just to see that we work and the society work. He's a seasoned researcher, a very big lab, passionate about education. There was this day he shared with me, Andy, look, my student is a first class graduate. And I was like, wow, so passionate what a teacher would do. So we're happy to have you here today.
Thank you so much. Anyway, thank you so much, Andrew, and thank you, DG. Thank you to my good friend Dario. We still have so many more trips to make to Africa. You know that. Yeah. So I just want to say thank you for welcoming me. This is me coming home. I'm actually Nigerian. But I've been away for close to 30 years. And I live and work in South Africa, all my adult life, and this is me coming home. And yeah, I'm surprised so many things has changed, and thinking close to 30 years, the first time I came, this man and my good friend from Niger Delta, the VC, brought me in June. So when I came in June, I had a very good time, saw what people are doing in Niger Delta University, visited a couple of labs, see, beautiful things going on, in the world of biochemistry here. And our job really as FASBMB is to make sure we coordinate the African, space of biochemistry and make sure the opportunities that are there are actually made available to people so that you can grow the science that you do. A thing that I do more, which is my little way of giving back, is to I've got a lot of Nigerians in my lab. So every now and then they come in, do their master's, PhD. But just like Dario said, a lot of them doesn't want to come back. I have like about 4 of them who left last year to the US. So after they finished their PhD from me, even there are some I said, wait to do postdoc, they just, no, we've got a position in the US. So the idea, like he said, is to make sure the best brains, after being trained, comes back to Nigeria so that as to continue the training of other people. I'm really excited to, I already told the president that I'll surely will come next year to Akure. I'll surely pay my way down, as usual. I really do. So I'll come to Akure next year to your NSBMB Congress. Try to see if, at least tell you guys what I do, what my research is about, and what strides we've been making. So I'm happy to be here, and thank you for having me. And DG, thank you for availing your resource to the Biochemistry Society. And we're really grateful for what you're doing. I'm happy that you are also a biochemist. So I just hope we'll be able to talk some science, away from the admin that I know takes all your time at meetings. So I'm just happy that you avail your time and your presence here today. Thank you so much for all you do. And thank you, everyone.
Thank you, Professor Paul Castle. Before I call the next person, let's put our hands together for him. The next person is no other person but our president of NSBMB, the person of Professor Matthew Wonder Webb. He is the reason why we are here today. Very energetic, very passionate. I lack words to describe his erudite scholar. Professor Matthew Webb has given it all, blood, sweat, and time, to make NSBMB what it is today. He has traveled far and near for every occasion. He's there. He has been to ABU, he has been to Bauchi, he has been to Port Harcourt, he has been to everywhere to show passion, to show his passion, to show his support wherever any project is being coordinated. He wants to be on the lab, he wants to be on the bench, he wants to let the students have that feeling. NSBMB is a society that is worthy of emulation today because of this gentleman. Ladies and gentlemen, present Professor.
What it should tell us is that the modern father of NSBMB is right here with us. The man who took it upon himself to ensure that NSBMB survived, and his name is Professor Bilbis. So if anybody is thinking that I have sacrificed anything for NSBMB, the real man who gave his all for the survival of NSBMB is him, and I see him as the father of modern NSBMB. And Professor Dario, we have come for this thing. Let me just hint you. In fact, the real reason we had to change the date, apart from your own schedule, was that we agreed that the younger generation of biochemists must interact with you. Must interact because we know that there are so many great openings out there that our people will benefit from. And we are very grateful that this day will come, and it has come, and it has come to stay. This is not the right time for much speech making, because time is no longer on our side. So these are all my colleagues. All of us have worked together. That's Professor Omar, you know him, Andrew, we know Uche is our PRO. He's in charge of our journal. He's our editor-in-chief, very great man. Very soon our journal is going to be in one of the scopus. Dr. Okodua is one of us. He's our Director of ICT, and then the Secretary General. I guess we look alike. Very energetic and very wonderful young man, and the man behind the scene that the probabilities I want to tell you, massive. It's a blessing to NSBMB. There is no NSBMB. It's not an academic. It's not an academic per se. It's a biochemist. That's a PhD in biochemistry, and it's a staff of one of the most powerful companies in Nigeria. He is the director of that company, but he humbled himself to accept the position of.
Which company is that?
Okay, the company is a Chinese company into civil engineering construction.
It's an engineering construction company.
Yes.
So, and willingly he accepted that offer to occupy the position of director of exchange and linkages. He has done so well for NSBMB. Like I said, okay, we have the vice president is even here. Yes, Professor Milala is a gentleman you love to know, and we have. Please, let me introduce him in a special way, sir. The man you have here is our pride. Africa will be very proud of him. In fact, he's one of the plenary speakers, and he's going to talk on single cell research. He's an expert in that area. Dr. Ido. When we see him, we normally bow so low. It's an epitome of knowledge. We thank you. And then there's one great Balogu here, Professor Balogu, who has sacrificed. Come, they need to know you. He has sacrificed his all for the educational advancement of our people. And he's a thorough biochemist. He's an international scholar. He came in here with his tools to ensure that this program, that nothing happens to it. And I know he's going to even give us those tools for free. The president has spoken, and nobody can. Those things will be there for free. Don't mind those equipment you talk. That has been the spirit, sir. Spirit behind the NSBMB. Everybody wants to give his best for the survival of our society. Is there another question about this? Yes, my big brother here is our Southwest Zonal coordinator. He's another elder scholar. He's widely published, and we're very proud of him. Sir, Akim with me, Dr. Akim, yes. We are glad you're here, and it is our belief, and we strongly believe that your coming is going to be a great blessing. On this note, I want to inform you that we have resolved that you are now in Nigeria.
Like he said, since we came to know each other, it has been so wonderful. So, I welcome you especially to Nigeria, and in particular, Sheda Science and Technology Company. As a matter of fact, I was not expected to be in Nigeria today.
And I prayed.
I hope we did some. We mixed a lot of chemicals and then they did. Yeah, because my daughter will be communicating tomorrow, and I wanted to be with her because that's the second master's she's having. So it's okay. I've not attended any of the convocations and attend this one. But somehow, because we have a new minister, not because of because we have a new minister and he has given me a lot of assignments, so there's no way I can leave the assignments for this now. And like you said, one of the problems we have in the country is our best will go out, they will come back. And I recall in 1999, while I was in Germany and ambassador visited us and invited all the Nigerian professionals in Berlin, and we went to him and he told us that he wants all of us to to come with and work with me. And somehow I put down my name as one of the people that can come back, and that was how today. I know many of us that were in Germany then as Humboldt Fellows, only very few came back. In as much as one of the conditions for Humboldt Fellowship is that when you finish, you go back to your country.
Yeah.
So what many of them did was they would just come back, spend 3 months, 1 year,
Go back.
I'll go back again.
they will leave. But yes, when you come back, you have a little frustration at the initial stage. But if you persist, you discover that all those things are just ordinary challenges which you can overcome. So here I am. Though I have a meeting in the ministry by 1, but I insisted that I must, because the meeting was supposed to be 12, I said, okay, let it be 1 o'clock so that I'll be able to meet.
But that's in the budget, to go.
Yeah, it's in Abuja, but in the headquarters. So you are welcome. I'm a biochemist. My first degree is in biochemistry, master's in biochemistry, PhD in biochemistry. And one thing that I thank God for, and why I'm so passionate about biochemistry, was that some people will tell you that they missed medicine, that's why they read biochemistry. I read biochemistry because I wanted to. The reason is that somebody challenged me because I take palm wine. Challenged me that I will not know, my father doesn't know how to tap and I will not also know how to tap. So during my youth program, I asked one of the facilitators, which area of study can I go and I will know how to synthesize palm wine? And he said biochemistry or microbiology. Biochemistry sounds better, so I think biochemistry.
Good decision.
Yes. So the essence was to see whether I would synthesize palm wine in the lab. And my first, in Benin then we have what we call pre-project and project. In my pre-project, I worked on Pito and Brukutu. I was able to produce Brukutu and Pito and it was so wonderful. I said, okay, I'm on my way to palm wine. So, unfortunately, the same man that helped me to work on the Pito, I didn't know he was working on palm wine. Before we knew what was happening, he announced that he can produce palm wine in the laboratory. That's the late Professor Ekundayo of University of Benin. I hope many of us will have known. So he was the person. So I got disappointed. I said, okay, I will continue. And then ended up specializing in food biochemistry. And then I PhD in the effect of using radioactive materials in food processing. So you are welcome.
Thank you very much.
I will, whatever I can do to support biochemistry in Nigeria, at least some record. I was the pioneer, head of department of biochemistry of Nasarawa State University. Because that was the second invitation. I was invited to Gambia to establish biochemistry department. I didn't go. And then when I was called again to come and establish biochemistry in Nasarawa State University, I said I must go. And that was how I was able to establish biochemistry in Nasarawa State University. And then also their PG school. So you are welcome. I will, at least for today, I may not actively participate. Because immediately if we leave here now, I will jump into the vehicle my way to town. However,
thank you all. Please be seated. Again, you are all welcome to the educational workshop of the Federation of African Societies of Biochemistry and Molecular Biology being hosted by the Nigerian Society of Biochemistry and Molecular Biology. Everyone seated here is a dignitary and you're all welcome. However, we would like to introduce some of our special guests who are here and are invited for this very august occasion. Permit me to commence this introduction from the President of the International Union of Biochemistry and Molecular Biology, in the person of Professor Dario Alessi. Professor Dario Alessi, you are welcome to Nigeria, to Abuja, for this very august occasion. Permit me to welcome the President of the FASBMB, the Federation of African Societies of Biochemistry and Molecular Biology, our very own Professor Suleiman Lawal Bibis. You are most welcome. Also with us here this morning is the Vice President of the Federation of African Societies of Biochemistry and Molecular Biology, Professor Paul Capo, who is coming from South Africa. It's important to note that Professor Capo is actually a Nigerian, but he's been based in South Africa for over 3 decades. You are most welcome. Of course, the Nigerian Society of Biochemistry and Molecular Biology is hosting this event, and so dear members of the society, delegates, national and international, and even non-members here present, permit me to introduce the President of the Nigerian Society of Biochemistry and Molecular Biology, the person of Professor Matthew Obonda Wegu. We recognize the presence of very eminent professors of biochemistry and molecular biology here present. We do not take your presence for granted. However, permit me, as we say in Nigerian parlance, to observe all other protocols. So, without wasting much of our time, I would like to just ask the members of the LOC here present to just simply wave their hands, be on their feet and wave their hands in appreciation for the work they've done so far, the NEC members and the entire members of the LOC, for actually putting this program together. I now quickly invite the President of the Nigerian Society of Biochemistry and Molecular Biology, Professor Matthew Obonda Wegu, for his opening address. Please, let's give him a round of applause.
An address presented by the President of Nigerian Society of Biochemistry and Molecular Biology, NSBMB, Professor Matthew Obonda Wegu, at the opening ceremony of the Federation of African Societies of Biochemistry and Molecular Biology Educational Workshop, protocol. I want to sincerely welcome the President of IUBMB here present, and the President of FASBMB, the Vice President of FASBMB, members of NEC, distinguished scholars, both Nigerians and non-Nigerians who are here present. Please, the non-Nigerians present, please, I urge you to feel at home. You are in Nigeria, and Nigeria is a home for all. It is with great delight and utmost humility that I welcome you to the 2025 FASBMB Educational Workshop. I also feel deeply honored to be part of these great minds that are gathered here today to discuss a theme that captures the vision of our continent, including our scientific ambition. Distinguished guests, the theme of this workshop will be absolutely relevant if it is viewed as a call to action rather than a mere slogan. It is common knowledge that our continent currently stands at a pivotal moment as life sciences in most parts of the globe are being reshaped by automation, artificial intelligence, advanced instrumentation, and high-throughput molecular tools. In today's world, these technologies are identified as the engines that drive modern inventions and discoveries in health, environmental science, agriculture, and biodiversity and biotechnology. Distinguished guests, this moment offers our continent an extraordinary opportunity that is structured to enable us leap forward rather than catch up. Fellow Africans, this moment presents an opportunity to embrace advanced technology as it would enable young African researchers to bypass long years of limitations and begin the building of functional laboratories, innovation hubs, and research programs that will be relevant on a global scale. Permit me, ladies and gentlemen, to bring to your notice that biochemistry and molecular biology are currently at the heart of major challenges that the continent is facing. And this will include public health, environmental sustainability, agriculture, industry, biotechnology, automation, and modern molecular technologies. For decades, as you are aware, researchers in Africa have been constrained by limited access to equipment, costly outsourcing of samples, and very low turnaround time. With automated systems, coupled with locally equipped high-tech laboratories, we surely can, number one, keep African samples on African soil. 2, protect our intellectual property. 3, train our experts and accelerate our indigenous solutions for the challenges on the continent. In my view, this is scientific sovereignty. I repeat, this is scientific sovereignty, and it is absolutely necessary. And it is absolutely necessary for the security of our health, economic independence, and global competitiveness. Distinguished guests, there is the urgent need to invest in the people who will use the technology, as technology alone will be irrelevant if there is no one to use it. African leaders should therefore consider the training of young scientists that are ready to drive the next century of discovery. Such training should be in molecular techniques, strengthening skills in computational and bioinformatics, building strong mentorship pipelines, and fostering town and ground partnership using the triple helix model. Ladies and gentlemen, it is my belief that with the right training and support, young African scientists will be transformed into pioneers of global biotech innovation. I am aware of the existence of challenges such as gaps in infrastructure, delays in procurement, high cost of consumables, and the need for biosafety. As Africans with high spirit of resilience, we must not give up. Rather, I encourage us to face the challenges with courage and strategy. African scientists should see these challenges as design instructions rather than roadblocks. These challenges are often there to direct us to the appropriate place to invest, including how to plan, when to execute our plans, and the appropriate place to collaborate. I am confident that with strategic partnerships, local manufacturing, and policies that are forward-thinking, we shall overcome the challenges. Fellow researchers, the hope that burns within my heart is that Africa is on the path to greatness as I see a new Africa where, number one, sequencing laboratories run autonomously in African universities. 2, automated platforms assist in the design of vaccines and therapeutics tailored to African population. 3. Molecular diagnosis can be developed, validated, and mass-produced on the continent of Africa. 4. African scientists lead startups that transform research findings into real products such as vaccines, enzymes, bio-based materials, etc. 5. Africa becomes a global hub for innovation and no more the Africa that is a consumer of imported technologies. My dear Africans, this vision will be real if we have the courage to build it. May I conclude by reminding us that redefining biochemistry and molecular biology in Africa is simply about agency, innovation, and the future that we choose to create. If as Africans we have ever needed to invest boldly, collaborate widely, train, innovate, automate, and elevate African science to heights the world cannot ignore, it is now. Distinguished guests, I can hear calls from the next era of discovery, and the global scientific community is aware of this call. As Africans, we must not only answer this call, we must lead. The future of biochemistry and molecular biology cannot be imported. It should be invented on African soil by Africans empowered through technology. Distinguished ladies and gentlemen, once again, you are welcome to Abuja. Thank you and God bless.
Please, another round of applause for Mr. President. Thank you, President, Nigerian Society of Biochemistry and Molecular Biology, for that powerful speech. We hope that it will energize and indeed synthesize further thoughts and research in biochemistry. Permit me, ladies and gentlemen here present, to welcome here with us now, right now, is the Director General of the Cheddar Science and Technology Complex, Professor Paul Chidozie. You're welcome, sir. We actually didn't think he was going to make it, but we are glad to have him join us this minute. Delegates present and those who are joining us live online, please, we also have our online platforms, and members, both in national and in diaspora, are enjoined to join and participate actively in this educational workshop. So permit me, ladies and gentlemen, to welcome the President of the Federation of African Societies of Biochemistry and Molecular Biology, former President of the Nigerian Society of Biochemistry and Molecular Biology, and the former Vice Chancellor of the Usman Danfodio University, Sokoto, Professor Lawal Suleiman Biwis, for his introduction.
Thank you, my brother. The President of the International Union of Biochemistry and Molecular Biology, who is a special guest here, Professor Drayo, the Vice President of the FASBMB, my brother Paul, my friend, another Paul, who is the DG of this complex that we are here, all of us are witnessing. Thank you once again for welcoming us to your home. My fellow members of a NSBMB, because I'm still a member, students that are here, you are welcome to this educational activity being organized by NSBMB in collaboration with SHESTCO, being supported by FASBMB, and being funded by IOBMB. So this is a joint activities by 3 or 4 very important units of the biochemistry family in the world. What we have today, we have the world of biochemistry here with us, having the president of IOBMB with us. This is the first activity of FASBMB in Nigeria where we have the president attending. Thank you, Mr. President. We sincerely appreciate your effort of coming to Nigeria. Despite the negative news you received from foreign media about insecurity in Nigeria, he flew from Birmingham to Frankfurt, then to Abuja yesterday. He's only staying here today and tomorrow he will fly back home. This singular honor make this activity wonderful and very memorable. The last time FASBMB was in Nigeria for a workshop, I think it was about 15 years ago when I was the vice president of NSBMB. And then today, and we pray so many activities of other FASBMB or IBMB will be hosted here in Nigeria. This is our request to Mr. President. Today we are here for a hand-on training for our colleagues on the modern techniques and methodology in biochemistry. Biochemistry is no longer what it used to be when we are only teaching DG SHESTCO. Now biochemistry have gone molecular. Almost every aspect of biochemistry has one molecular research or another. So we are now merging the biochemistry to molecular biology into molecular sciences. For FASBMB, we have one activity now that is Pro-Bio Africa, where we send advertisement every year for PhD students to go into Europe to conclude their work. This activity is being funded by IBMB and FASB, the Federation of European Biochemical Societies. We had a discussion this morning with myself and the Vice President and also the President, the possibility of introducing another movement, but this time within Africa, where we move across African laboratories to do one work or another. This we are going to discuss at the council meeting of FASBMB. Then we approach IBMB the possibility of funding either from them or other regional bodies to see how we can fund our researchers to move across Africa. For example, we can send researchers from Ghana to Ahmadu Bello University Zaria. We can send researchers from Monrovia to University of Lagos. We can send researchers from Usman Afodo University to South Africa. Let's see how we can increase connectivity and activity between the African scientists and how we can improve molecular sciences in Africa. This will not affect the Pro-Bio Africa we're having now, where we move researchers from Africa to Europe. In addition to that, we also want to enter into discussion with IBMB to see how we can improve this. Another aspect we are trying to also do is we started discussion of this, I think, about 12 years ago. Possibility of European scientists to come into Africa for one semester or 1 month or 1 week. Thanks to the COVID-19 that comes and improve the virtual lecture series. So we are having a discussion with the president of IBMB to see how we can encourage scientists across the world to pick one PG course in some African universities that will deliver virtually. This will increase the collaborations between African universities and European and American universities. It can increase also interconnectivity between researchers in Africa and the rest of the world. And this will improve the way we teach our PG programs. This will also lead to a way of writing joint research grants between the university where the European biochemist is teaching and his own parent university. This also is something that we discussed at FASBMB and also approach IBMB and FASB and other regional bodies to see how we can come in to do. Last 2 years ago, we started a virtual FASBMB lecture. This we are going to reintroduce back, God willing, in 2026. We are going to have a bi-monthly virtual lecture for FASBMB. We are calling on the president of IBMB to kickstart the 2026
FASBMB virtual lecture. Professor Dario, we want you, if possible, to look at your calendar between January and February for a FASBMB virtual lecture. This we intend to sustain every 2 months. We do one lecture, so we have 6 lectures per annum, starting 2026. And we want the President to launch the 2026 FASBMB virtual lecture. After that, then every 2 months, we also invite other African in diaspora or other biochemists across the globe to deliver lecture relevant to biochemical sciences and molecular sciences in the world, because science does not know any boundary. Just some of the activities the FASBMB is planning for the 2026, God willing. As we gather here today, we pray for Almighty to guide and protect this activity and all other activities that we are going to do during this and also throughout our life. Despite the traffic jam in the Gwagwalada, we still have this sizable number of people getting through. And we were told by the organizers that we have over 400 people registered, both physical and virtual, to be here today. This is something very unprecedented for a FASBMB activity. Thank you all. Thank you, Mr. DG, for allowing us to use your opportunity. Thank you, and may God be with us.
Thank you, Mr. President, for that very opening remark. I'm sure many of us here heard what he said with respect to openings for research and collaborations. At this point, I will be inviting the Vice President of the Federation of African Societies of Biochemistry and Molecular Biology. He will be sitting in or standing in for Professor Ibar Parker, the Secretary General of the IUBMB, with his speech. His name is, of course, Professor Abidemi Paul Kapo. Please, let's welcome him.
Okay. Thank you so much, and I'm happy to be here this afternoon. I actually have no idea it's afternoon until I'm told it's already close to lunch. And lunch is something that I basically don't joke with, because that is the only time that I really have to enjoy myself and, eat good food. I'm happy, being here today with you guys. I'm so happy that I could meet with so many young people and also established researchers. I basically have gone onto your website a while back when you had the meeting in Kefi. So, and I was really impressed with the turnout at the meeting in Kefi, and it was just a pity that I couldn't join, I couldn't join you in Kefi then, because I came to Nigeria at that time. I was invited to Niger Delta University, and I was there. So it was just like a week after I left back to my base in South Africa that eventually you guys have that meeting. If I had knew, I would have basically, spent some time over there and, but I've already promised your president and the ESCO that God willing, I will be in Ado Ekiti for your next NSBMB conference. Yeah. And I'm happy to pay my way down, so don't worry about trying to buy me a ticket. I'll surely foot my own ticket and everything. IUBMB basically is made up of about 100,000 biochemists and molecular biologists, and also affiliated disciplines in about 77 countries of the world. So we've got over 100,000 biochemists. So I'm part of that. Over 100,000 biochemists happens to be you guys that are sitting here today. And we have regional organizations, within IUBMB. So what happens is that IUBMB doesn't work with individuals. So IUBMB works with the regional organizations, and the regional organizations, you know, within Africa is called the FASBMB, the Federation, it's called FASBMB, which is the Federation of African Societies of Biochemistry and Molecular Biology, where the Nigerian society is actually part of that, and the representative basically happens to be Lawal. I think it's just left. Okay, so Professor Bilbis is the representative of NSBMB at FASBMB, and also he serves as the president, while I serve as the vice president, but I represent South Africa and not Nigeria. So, and then we also have FEBS, which is the Federation of the European Biochemical Society, and you have the Pan-American Biochemistry and Molecular Biology, which represents the Americas, that is your South America, and then we have the FASBMB, which represents the Asia and Oceania region. So that is the composition of the IUBMB membership. Now, so when you look at the executive, like you know, the president is here, which is Dario Alessi, which is from the University of Dundee, and then we've got a president-elect, which basically is the vice president, but we call it president-elect. That is, the way IUBMB is structured is such that immediately Dario finishes his term, the next, person is already known, which happens to be Sanya Visvawaria. So she is the president-elect, and she's from the Indian Institute of Science. And then we've got a treasurer, which deals with the whole of IUBMB finances and everything, and his name is Loredano from Italy. And then James Murphy, which is in charge of publication. So what you notice is that one of the things I would like to talk about is that IUBMB has various research journals which you can publish in. But what I just want to tell you guys is that just in recent past, not too long ago, there are some of the journals which were open to Africa. I still don't know if it's still open, because I got to publish 2 papers, a review article and a research article, and it was for free. So, and I wrote to various people there who should be able to pass the message across that there is a special issue which you can publish and you don't have to pay for anything. And I think it was on aspects of molecular medicine. You will see when we get there. So that is some of the, some of the benefits that you can get when you, when you basically go to the IUBMB website, and you can see various things, opportunities that are available over there. So some of the opportunities, some of the things that IUBMB does, basically we talked about the triennial congresses, and the next triennial congress is going to happen at Cape Town, South Africa in 2027. So this is me today welcoming you all to South Africa in 2027. I hope to see many of you in South Africa. There is a fund which is called the Young Scientists Program, which basically look at young people attending the Congress before the main Congress starts. And that you just have to apply. Once the application is open, we will post it on the FASBMB website, and I'm sure we'll send it to your president, who will post it on the NSBMB website, and you can apply to attend the YSP. But the good thing about the Young Scientist Program of the Congress is that after you've attended the YSP program, it also gives you an, passage into the main Congress itself, where you don't have to pay anything you don't pay registration and everything, and you are able to attend the main Congress, and where you can meet up with renowned researchers and you can network, talk to them, tell them about what you do and what opportunities are there. They are able to tell you, and it goes on and on like that. Then the other things we have is focus meetings. Focus meetings basically is, before the Congress is held, there is always an application for societies to host focus meetings. And the last focus meeting was held, I think, in New Zealand, it's New Zealand, yeah, which actually speaks to kinases, if I get it correctly. Yeah. So that was the last focused meeting, which was in New Zealand last year. And then there are various awards and lectures. There is the Golden Jubilee lectures, which basically may be open to our established and renowned researchers who basically can, the NSBMB can apply to that. You can apply for somebody to give, those lectures at a meeting. So, and then we've got the advanced schools, we've got the young scientist program, which I've spoken about. Then we've got the IBBMB FEPS events. The IBBMB FEPS event is actually what Lawal just talked about, where basically the one that concerns Africa is the Pro-Bio Africa. And Pro-Bio Africa, let me just explain it to you, because I think Africans, we are really not getting it. When we started that program the first year, we advertised far and wide. We only got 10 applications, of which 7 were funded. And the 7 that were funded, 4 were Nigerians. So I think you can clap for yourself for doing that. So, and one of the applicants that was funded was this person from, I can't remember the university, but somewhere from the East. And I know the person because when he wrote his progress report to us, I was telling the president just yesterday night, it was one hell of a work, of a job that he has done. He did so much in 6 months that we have to actually renew for him to go back to Spain, because he was in Seville in Spain, to actually do another 6 months. So that's to tell you how well, if given the opportunities, some of the young people can actually do a lot of work, and good science can actually come out of there. It's just a pity I forgot the guy's name, but I know he's from either Nsukka or University of Nigeria, Nsukka. One of the, if I check my laptop, I'll surely will find his name out. But he's still there now or maybe he's returned, I don't know, but he really did very good science over there. His host over there actually has to write a motivation to us to again ask for a renewal for him. And when we saw the progress report, it was good science that he has done in just 6 months. So the opportunities are there. Please, once the Pro-Bio Africa, comes out, please apply. We know we get, and we don't restrict, our federations or societies in applying for that. We can have as much as 20, 50 applications from Nigeria. As long as your proposal is very good, it makes sense, and is doable, and you can find also a host in Europe, then you are good to go. So please don't miss that opportunity. And so that is actually the one I want to talk about. There is the other one which we call Novogenesis, which for now is still between South Africa and Kenya. But as time goes on, speaking to Dario, we will basically open it up to everybody within Africa. As time goes on, that one is not open to Nigerians yet, but I'm sure we will open it to Nigerians later and other parts of Africa. So you can see our triennial congress, like I said, last year we were in Melbourne, Australia. Again, that was what I was telling you about, looking for KFC to eat in the night, and then Cape Town, South Africa. And I can promise you, one thing that we do best in South Africa, when I say we do best in South Africa, is we work hard and we party hard. So that I can tell you. And South Africa has the best wine in the world. We produce the best wine in the world. And we also play good football, better than your Super Eagles. Actually, we qualified for the World Cup, and the Super Eagles are not going to the World Cup. So sorry about that. So yeah, so it would be nice to come to Cape Town. Cape Town is beautiful, the Table Mountain, and we're actually planning to have you guys come and have a hell of a time. It's also the party capital of South Africa. So when you come talk science during the day, in the evening, there's always an event going on. And it's also close to the sea. It's just next to the sea. And I know some of you have been to South Africa, you know Cape Town. Close, we have something called the V&A Waterfront. So we will be having that meeting, Congress at the V&A Waterfront, the ICC over there, which can accommodate close to 10,000 people. And come and see for yourself, you know, the good science that is taking place. We really, really want to encourage Africans, and we want a lot of Africans to come over. And even though the YSP has received money, good funding from IUBMB, which all thanks to IUBMB, I think we can put a round of applause for the president. Also, we as FASBMB, we've also put some money aside to again fund some young African students to come. Now it's for the students, you know, the young students, not for established researchers. So towards the YSP, so that they can also partake in the main Congress. So I'm looking forward to seeing you guys in South Africa in 2027. I will personally welcome you to South Africa in 2027. I will be at the airport trying to welcome everybody that comes over, and I'm sure I will see many, many of you come to South Africa in 2027. So I've talked about focus meetings because of our time. I think we have educational workshops. So these are the various fellowships that we do. This is a fellowship which is basically for Zimbabweans, and this lady, Tatenda Murigo, was actually one of our very, very good young biochemists, and actually we were in a meeting with her. She was in a vehicle, and we were having a Zoom meeting, and the vehicle was involved in an accident while she was actually having a meeting, you know, with us. So, and she passed away from that, you know, from that accident. So, and that was how the former president, Professor Alexander Newton, you know, started something, scholarship on her behalf, you know, for Zimbabwean students. So that was Tatenda, and then this is the Pro-Bio Africa I've spoken about. This is the Enable African Fellowship, which is for PhD students and postdocs. And we've always have Nigerians there. I think one guy, Olushola, something from the southwestern side, was actually part of this Enable conference in the past. So there are so many Nigerians who have been partaking in all these meetings. And then there's the Wood-Wheeler Research Fellowship. Now, the Wood-Wheeler Research Fellowship is for you to also go to anywhere in the world, not Europe now, any lab, anywhere. You just write a small proposal, which is about 1 to 2 pages, and then you fill in the forms and you submit. And we sit on it and look at the applications. And we've done the first round. For the first round, we've done that for this year. The next round will come out, I think, around something March, April. Please look out for that. That gives you about 5,000 euros to go work in any lab, anywhere, any lab, anywhere. And the targets, you see, the issue with that is that we get a lot of South Americans, Argentines, and Brazilians applying. And the Wood-Wheeler, we hardly get, you know, Africans in the Wood-Wheeler. The last application we looked at, there was only, I think, 1 or 2 Africans in that application. And that was really bad because I sit on that committee and I looked at it. That wasn't good for us at all as Africans. Please, once it's out, check up your NSBMB web pages, your FASBMB web pages, and you will get all these, all these opportunities. The opportunities are there. The travel fellowship as well. If there are other conferences you want to attend, the travel fellowships are also there. They are available for you guys. So don't just box yourself to a corner to say, no, I don't have funding. And if I will advise you, don't apply for this funding once and say, oh, I didn't get it and eventually I won't do it anymore. Please apply for it as many times as possible. You may just be lucky to get this funding. So, and then these are the journals which I talked about before. These journals are floated by IUBMB. I mean, I can tell you something. Trends in biochemical societies, impact factor is more than 15. You see, for us, like for us in South Africa, it's not only to write, papers, but you also have to publish, in very high impact factor journals. So you can basically send your publications to any of these 8, research journals. This is the one I talked about, aspects of molecular medicine. They actually ran a free publication thing for a long time. I don't know if it's still open, because I published 2 papers in there. One of my master's students' work was published there, and the other was a review paper by a PhD student of mine. And it was open for a very long time. And also, there was a special section for Africa, which is called VSI Africa. And one of the editors there was Professor, what's his name? Okpara or something. He's in South Africa, but he's affiliated to University of Nigeria. If I remember his name very well, his name is Umezuike something. Okpara, yeah. He's actually one of the associate editors of that VSI Africa. So check it up again as you're sitting. You can check it on your cell phone and see if it's still open, where you can publish your work free. So please use these opportunities. They are always available. I know funding, paying for publications is not easy. I can tell you that. Even with us who have money, it's not really easy paying, some thousands of rands to publish. And when you want to publish good science costs. Let's be sincere. But you can also get some of those free journals, even though the quality sometimes may not be as you want it to be, but you can use any of these. The last thing I'll talk about before I hand over to who will talk next is there is this journal, Biochemistry and Molecular Biology Education. We really don't talk about that much, and I want to tell you, this is a very, very important, journal. I'm actually planning to actually publish in there next year, in the sense that, is there any, any out-of-the-box ideas that you use in teaching biochemistry, in your environment, looking at various strategies. What is that strategy you've used to increase your pass rate? So those are the type of things that this journal talks about. This is Biochemistry and Molecular Biology Education journal. So what are those strategies, from this whole COVID-19, era, where we all have to do blended learning and all those blended teaching? Have you come up with any, brilliant ideas? You can actually write that up and submit to that journal, because it speaks to education of biochemistry. So not just research per se, you can also do what we call normal discipline people in art do, where you do questionnaire. Also you can give to students, is there any new strategy you've applied to make sure you increase pass rate, your student understands what you are teaching better, or whatever things you've done. That can all go into this journal called Biochemistry and Molecular Biology Education. Please look at all this, and I think lastly, so there's something that's called the training initiatives. So the training initiative, you can see this is for FASBMB in Africa, and we've got Aisha Tumalami, who actually the training leader within Africa, but she comes from Nigeria. So you basically can speak to this. This training initiative is actually for people who are being trained to have leadership roles later on. So if you are a PhD student or postdoc, this is the person to speak to. So these training initiatives, you can see various people from various countries in Africa. So please look at all these. Go to the IUBMB website and look at all these opportunities and start putting up things together so that you can enjoy it. And lastly, the world is a social media place of late. So you can actually, what do you say again? You can follow IUBMB. I used to cast a joke. I don't know if it will be appropriate here, my joke. The sense that I used to ask people that, when Jesus saw, what's the name? Andrew and the ones, those disciples of his who were fishing, what did he say to them? He said, follow me, right? So you can follow IUBMB, on this. So I used to make the joke that Jesus was the first to use social media when he said to them, follow me and I will make you fishers of men. So so you can follow IUBMB on X, which used to be Twitter, and then you can follow, Facebook, YouTube, and so those are the social media handle of IUBMB. So because of our time, I think I've spent a couple of time trying to explain all this. So thank you once again, and I look forward to you, because I will also be giving a talk at this conference, my research talk. So this is just to give an introduction on what IUBMB does. And thank you very much for your attention.
Happy for that presentation on the IUBMB. I am hoping that soon we'll be having Nigerians taking over all of those opportunities available for those short research and training programs. Permit me to welcome our host, the Director General of the Sheda Science and Technology Complex, Professor P.C. Oyenebe, for an opening remark. Professor Oyenebe, you're welcome, sir. Please let's give him a round of applause.
I'm a very long man. If I stay here, you won't see me. Yeah. Our dear President of IUBMB,
Are you getting some?
Yeah. Our dear brother, Professor Davis, I hope he's making some reasonable contacts outside. The President of the Society of Biochemistry and MolecularBiology Nigeria, and all the officers here present. I will simply say I welcome all of you to this complex. When the President contacted me that they want to have this in Abuja, I thought that my duty just like the John the Baptist points to the place where you should get a hall. And it's beyond that. This year, Sheda Science and Technology Complex co-hosted the National Society of Biochemistry and MolecularBiology Conference in Kefi. We co-hosted that because I happen to be the pioneer HOD of Biochemistry, Nasarawa State University. So I welcome you to this complex. It may be necessary for me to mention that the essence of establishing this place is to make provision for people to have opportunity of using some of the facilities here at a very low cost effective basis. You can't compare with commercial labs where you go there. Another very important thing about the complex is that we are involved in structured training. We are involved in structured training. In that case, we are looking at some of the topical issues that people probably may not understand very well. So we take such issues up and do have some hands-on training on such techniques. Here also we have a journal, because one of the major mandates of this place is to ensure that science is well documented. And the only thing you can do to document your research work is to publish it. So that's one of the other things we do. And again, we collaborate with institutions. We collaborate with institutions, both the private sector and the public sector. We are working with so many universities in handling some of their courses and also supervising students. Some of the PG students, they come here, make use of the laboratory facilities to carry out their research work. And the only benefit of the place is that when the paper is published, our staffs who participated in that work are taken as co-authors. And that's why we don't charge you much. So I believe that after this, we are going to have a lot of discussions. I don't believe in lengthy writing. So simply, you can easily pick my number and call. If I don't pick your call immediately, definitely believe that later I will respond. I will call you. So feel free, interact with some of our staff, because some of you may be going to the labs. Interact with some of our staff. We have different areas, different centers. We have Physics Advanced Research Center, Biotechnology Advanced Research Center, Chemistry Advanced Research Center. Then we have Applied Mathematics and Simulation. It may interest you to note that recently we participated in the Kuwait Science Club, and some of the outcomes of our research here were able to give us a second place position in AI, and then third place position in herbal medicine. So, like I said, you are very free. Visit our labs, visit our websites. The contacts are there. Feel free, and my office is always open to everybody. Once more, I welcome each and every one of you, and I believe at the end of the day, because that's something that Fela used to say in those days. He said, I welcome you to my show. At the end of this show, you will learn something new. I like that something, that you will learn something new. Definitely our presence here and the time we'll be going, we will learn something new. Thank you and God bless you.
Okay, thank you so much for the very, very kind welcome and the amazing hospitality that I've received since being in Nigeria. It's a really great honour to be able to attend this meeting and to meet many of you and hear about the really important research that's going on in Nigeria in biochemistry and molecular biology. And I think the work that you're doing in Nigeria is so important for understanding human health, climate change, sustainability, and also agriculture and farming, and integrating all of this, harnessing this knowledge, and to help move the economies forward is going to be so important. And I think looking at Nigeria from the outside, I'm no expert, but it seems to me that you have an amazing country. You're blessed with amazing minerals, agriculture, fantastic weather that is so conducive to growing lots of crops and generating wealth. And you've got such a fantastic young population that is so well educated. You've got so many universities, so many passionate teachers around here that I've met. And although I see there's a lot of challenges with sometimes working in Nigeria, what's amazing is that despite these challenges, there's huge numbers of biochemists here and molecular biologists who are striving very hard to do fantastic research and teach the next generation of students. And this bodes extremely well for the country. And I've also noticed since I've been here, you're incredibly well organized. You come from many different regions of Nigeria, but you talk to each other. You know what's going on in other regions of Nigeria and Africa beyond. And you're really, really well organized, and you work together, it seems to me, very, very well. And that's a great strength and asset. So the only thing that's maybe missing in Nigeria is a bit more funding, and let's hope that the politicians who run Nigeria can realize the importance of investing in you and how important that's going to be for the economy going forward, and the number of businesses and pharmaceutical companies that could arise because of this. And with the dawn of AI, and all the other technologies that we have available to us in life sciences, it's going to be possible to design new drugs, new treatments very, very easily in the future, I think, much, much more cheaply than we can do them now. So you and your own universities could be really at the heart of drug discovery, making new chemical matter that's going to treat animal and human diseases and plant diseases, and exploiting this technology and building it, in Nigeria. So I think the future for you is extremely bright. And I think what was also said by Paul and others this morning was, I think, is really important. I think European countries, America and things, we have been exploiting a lot of the top brains in Africa, that we've been encouraged them to come and get training in Europe or America and other countries, and then keeping the people who go out abroad. And then after your government has spent so much time and energy educating them, and then they go abroad and they don't come back, and that's a loss of talent that you can really ill afford, I think, in Nigeria. So we need to think better and smarter how we can support you and enable you to get training internally, maybe within Africa, as we heard that scheme sounded extremely good, and I'm very happy to work with you to support a scheme supported by the IUBMB, and maybe jointly with the FASBMB, in which we we enable fellowships to be given internally within Africa to support, science that takes place here. So, that's going to be really, really important, I think. And I look forward to talking to you more, and please don't hesitate to come and introduce yourself to me, tell me what you're working on, tell me any challenges you face, and also maybe how the IUBMB could help. And if you need support for anything in the future, talking to your ministers and politicians, I'm happy to participate in any conversations that are needed just to help them appreciate the importance of supporting biochemistry and molecular biology in Nigeria and also in other African countries. So, okay, but now if I may, I might tell you a little bit about my research. Now I know it's after lunch. I know probably here no one is really interested in Parkinson's disease and maybe neurodegeneration, and then maybe also I also work in signal transduction and cell signaling and cell biology. But I'll give you maybe, let's say, half an hour of what I work on, just to try and give you a flavour of our research. And I hope you might find it interesting, and if not, you'll see some techniques, and I think signaling pathways sort of control all biology. So it's very likely that the biologies that you're working on and interested are controlled by signaling pathways, protein kinases, and the protein phosphorylation that might be relevant, even indirectly, to your own research. So I've always been really interested in signal transduction pathways, how a cell detects a signal, how the signal moves into the cell, and then elicits a physiological response. And to understand these pathways and how they work, how they're organized, but especially what's really interested me most is working out how these pathways are involved in human diseases. These are sort of pathways, highways of communication, and invariably cancer, neurodegeneration, high blood pressure, diabetes, inflammation are often caused by disruptions of these highways of communication, either by mutations that make the pathways slightly blocked and therefore the signal doesn't get down to where it's meant to go, or even too active, so the pathways are hyperactivated, and this drives signaling when the signal shouldn't be there. And and to understand this is really important, because it's at the heart of both diagnosing human disease and also working out new and smarter ways to better treat and even cure human disease. Because if we can sort of use small molecules to counteract the lesions that are caused by the defects in the signaling pathways, then you can develop new ways to treat human disease. So all the pathways I've always worked on have always been linked to signaling and been linked to a disease, and I've chosen pathways in which human genetics has revealed mutations in signaling components that are, in which we, at the time we started studying them, we knew nothing about the signaling components, except we had strong genetic evidence that it was involved in human disease. So I'm going to tell you about a protein kinase called LRRK2, LRRK2, that's involved in Parkinson's disease. And I'll just move this thing. And I started working on this pathway 21 or so years ago, and so I'll go back one slide here, so I'm going the wrong way. Apologies. This slide's different to the one I've got. Okay, that's fine. So this kinase LRRK2 was discovered in 2004, and it was by human geneticists who were had families in which were all over the world, in which they had inherited disease running in their family. So one of the parents had Parkinson's disease, the grandparents had it, the children had it. And you could see that it was a dominantly inherited mutation that caused Parkinson's disease. And this led to the gene hunters working out what the gene was that was mutated, and it turned out to be a protein kinase called LRRK2, which at the time no one knew anything about LRRK2 and how it was regulated and how it was functions. And as you can see, it's a very large protein kinase. It has 2,527 residues. It has 7 or 8 different domains. It has 2 catalytic domains as a protein kinase domain and also a complicated atypical GTPase domain that's located next to the kinase domain. And it's in fact one of the only genes we have in our body that have both a kinase and a GTPase domain within the same polypeptide. So just a few words about Parkinson's disease. I don't know if Parkinson's disease is very common or not in Nigeria. I suppose it is. It affects around 10 million people in the world. Some people get it older in life, but some people get it earlier. Some have it inherited, some have it due to environmental factors or unknown factors. And it is a very debilitating disease. Once you get it, it slows you down, it stops you doing the things you like doing, and it slowly gets worse and worse year on year. And at the moment there's no treatment that can slow the progression of the disease down. We can treat some of the symptoms like the tremors and then the slowness of movement by adding drugs that mimic the dopamine that's lost when people have Parkinson's disease in the brain. But this doesn't slow down the progression of the disease. So I guess the hope was when we worked on the LRRK2 kinase that we could maybe study how the mutations in LRRK2 caused Parkinson's disease, and we had sort of hoped that this could maybe someday lead to a better treatment for the disease. And then some of the mutations in LRRK2 were quite interesting because they're one of the most common causes of genetic Parkinson's disease. So probably 90% of people who get Parkinson's disease have what we call idiopathic disease, in which the genes or the cause of the disease is unknown, and maybe only 5 to 10% of people have familial Parkinson's disease. And if you take the group of that 5 to 10% of the people who have familial disease, LRRK2 is probably one of the most common genes, together with another gene called GBA1 that causes inherited Parkinson's disease. And there's one mutation in particular, the G2019S, that's in the kinase domain, that's the most common. I think 87% of people who have mutations in LRRK2 that have Parkinson's disease have this G2019S variant. So one of the first experiments we did as a biochemist, I was very interested to understand how does the Parkinson's causing mutation impact the activity of the LRRK2 protein kinase. So that's a very basic question that you always ask when you're working on genetics and biochemistry. And so what we did at the time, when this was back in 2007, a long time ago now, we made recombinant LRRK2, and then we developed an artificial kinase assay for this enzyme that we could measure its activity by finding a non-physiological peptide substrate that was phosphorylated by LRRK2. And as you can see, all of this was a very simple experiment. The result was very profound because it showed that the Parkinson's causing mutation in LRRK2 stimulated the LRRK2 activity. So it suggested that the activity was caused by hyperactivation of the LRRK2 kinase. And this was really important because it suggested that you could maybe make inhibitors that target the LRRK2 kinase as a treatment for Parkinson's disease. And then because of this work, many companies, and I'll come back to that, have started looking for drugs that can target and inhibit LRRK2. So our next question was, what does LRRK2 do in cells? What does it phosphorylate? And this was a very major body of work. So we worked from the year 2008 to 2016. It took us sort of 8 years of research where we used mice that we either knocked out LRRK2 or we made knock-in mice that had the Parkinson's causing mutation, G2019S. And we also got hold from the pharmaceutical company Merck, gave us a LRRK2 inhibitor that they developed called MLI2. So we had the knockout, the inhibitor, and the activating Parkinson's mutant. And then we did a lot of mass spectrometry looking for proteins that became phosphorylated in the LRRK2 dependent manner. And it took us 8 years to do this, but eventually, after all this work involving a lot of people, and it was a very collaborative project, we discovered that the key physiological substrate of LRRK2 was a group of other GTPase proteins that are called Rab proteins. So these are really critical regulators of cell biology. In the cell, we have about 70 or 80 Rab proteins that regulate all of cell biology, all the structures of organelles, the formation of organelles, the breakdown of organelles, where organelles are located in cells, the vesicles that travel from the surface to the organelle and back again. This is all regulated and coordinated by these Rab GTPase proteins. They're small little machines. They can exist in an on and off state. In the on state, they're bound to GTP, and they can bind to effectors through a motif in the Rab protein called the switch 2 motif. And this is the key business end of the Rab protein. And what's remarkable is that the LRRK2 phosphorylates the Rab protein right in the center of the switch 2 motif. This is the effector binding motif that binds to substrates. And it's a very robust phosphorylation. So, and it turns out, I told you we have about 80 Rabs in the cell, but only about 13 of them are regulated by LRRK2. And the ones that are regulated by LRRK2 are shown on this slide. And you know, this slide just sort of summarizes, as I've just said, all the different roles that the Rab proteins play in cells. These are really very underappreciated proteins, very hard to study because they just exist in an on and off state, and biochemically, when you break open the cell, they bind to their effectors with 1 micromolar affinity, so they dissociate, you know, before you can do mass spectrometry and analysis with them. And so they're not easy to study, so they're really sort of understood. And I just wanted to show you some data here of how this system works. So you have, if you look at the top panel on the gel here, I don't know, I probably don't know if I can use the pointer here, maybe. Yes, I can. So you can see this is the dephosphorylated Rab protein cells. And it's dephosphorylated. It's 99% of the protein is in the dephosphorylated form, but there's 1% that is phosphorylated, and you can see it runs at the high. This is the LRRK2 phosphorylated form of the Rab. And then when you incubate the cells with a LRRK2 inhibitor, this is 0.3 nanomolar, 1 nanomolar, 3 nanomolar. You can see you inhibit LRRK2 and therefore the Rabs become dephosphorylated because there's a very high level of a protein phosphatase called ppm18. So this was a very nice experiment. They gave us strong indication that the Rabs were the physiological substrates. Experiments I wanted to show you. This is another mutation that causes Parkinson's disease, and we made the knock-in mouse of this mutation. And as you can see, as I said before, the Parkinson's causing mutation activates the LRRK2 kinase. So you see more phosphorylation of the Rab protein. And then this is blocked with the LRRK2 kinase inhibitor. So this gives us strong evidence that the Rabs are really the physiological substrates. And then as a biochemist, we've actually spent a lot of time in my lab, maybe 5 to 10 years, making antibodies, with various foundations and companies. And then we've made all these antibodies available for the field to use, so everybody can access them. And this is one example of one of about 30 or 40 antibodies our lab has made in this area, and you can see these reagents are very useful for studying the phosphorylation of the Rab proteins and using these simple immunoblot analysis. So what I've really, I think, hopefully shown you in these slides is that the pathogenic mutations that cause Parkinson's disease activate the LRRK2 kinase. And therefore, because of this, you can maybe get inhibitors that could be used for the treatment of Parkinson's disease. And the assays I've described can be very helpful to not only develop the inhibitors, but then to test them in the preclinical animal models and now in human trials. And what's quite nice is that there's actually, I think, 7 companies now actually have LRRK2 inhibitors in clinical trials, and these are listed here. There's actually 2 companies that are entering phase 2 clinical trials with a small molecule. Biogen also have an antisense oligonucleotide that's injected apically into the brain, and this also lowers the LRRK2 protein expression. And then there's a list of other companies that are doing earlier stage preclinical trials. So it is quite exciting. There's never been a treatment that's slowed down Parkinson's disease, and we hope that it may work, but we hope will be useful for the treatment of Parkinson's disease, not only in people who have the inherited mutation, but also the 90% of people who don't have the mutation, because we think that a lot of the biology that LRRK2 regulates is also over-activated in people with the idiopathic disease. So you could evaluate treatment for people with idiopathic disease. So now we know the three-dimensional structure of LRRK2 that is shown here. You can see it's a very complicated structure, and this C-terminal half that contains the 2 catalytic domains of LRRK2. This folds into a very stable, inactive conformation. The kinase domain is totally inactive, and this leucine-rich repeat domain that's shown here in light blue, this actually wraps across the kinase domain and stops the kinase domain interacting with the Rab substrates. And this is a very stable structure, so when you express LRRK2 in cells, 99% of it is inactive. And then what we found now is that we've characterized many other variants that activate LRRK2. And the majority of these variants, what they do is they destabilize this active conformation. They're in domains, intramolecular domains between 2 domains, and the mutations weaken these interactions so that the LRRK2 leucine-rich repeat domain can come away from the kinase domain, and this leads to the activation of the LRRK2 protein kinase. And these variants, I won't dwell too much on this, but we've characterized over 60 variants now that are found in people with Parkinson's disease that activate the LRRK2 kinase. And many of them are in these domains, and then these ones activate the kinase, by destabilizing the inactive conformation. But what's really interesting for me now is that there are some mutations in this N-terminal region of the protein that can also activate the LRRK2 kinase. And this is located in this region of the protein here. And so this was a mystery to us. What could this N-terminal domain be doing to regulate the LRRK2 kinase activity? And so that's going to be the second part of my talk, is going to be on this, how LRRK2 is regulated normally in cells. So the way it's regulated is that normally Rabs, there's 80 of them I told you, 99% of the time they're regulated through this cycle that you'll see in all your textbooks, that there's a gap that converts the GDP to the GTP that causes the active Rab that combine to an effector, and there's a gap that reverses the Rab protein. And this signal, this is on, this is the off state, and Rabs are taken to membranes by different chaperone proteins, transfer them to different membranes in response to different signals. So, but then what happens is that what we've discovered is that when you have endolysosome stresses, and then
we're going to call, and there's many of these stresses that stress the endolysosomal system that maybe affects the viability of the lysosome or the pH of the lysosome or the osmotic balance in the lysosome or other organelle. Or the organelle is damaged, for example, you get a hole in the lysosome that leaks out some of the proteases that are inside it. This causes stress that has to be sensed and dealt with in the cell, otherwise it's going to have very serious consequences. And what happens here, I'm going to show you, is that LRRK2 is recruited to the membranes where the stress occurs, and a process called mitophagy. I don't have time to go into all of this downstream biology, but this is really critical for all the biology that's disrupted in Parkinson's disease. And too much LRRK2 activity negatively impacts all of these processes that are shown here in red. And then this can be ameliorated by adding LRRK2 kinase inhibitors. So, and in fact, many of the other genes that cause inherited Parkinson's disease that are listed on this slide are also disrupting this endolysosomal system. It's really critical for Parkinson's disease and also other neurodegenerative conditions. So the model that we have is as follows: that you have LRRK2 that's in the cytosol. In fact, in a normally healthy cell, 99% of the RAB is in the cytosol and it's in the inactive conformation. But when you have a stressed lysosome, there's a signal that somehow forms, it signals to an anchoring RAB on the surface of the lysosome. And then this recruits LRRK2 to that surface of the lysosome, where it then becomes activated, and then you phosphorylate RAB on the surface of the lysosome. And what we found, this is a summary of a lot of years' work. There's several RAB binding sites on the surface of this N-terminal armadillo domain of RAB proteins. There's one that binds a RAB called RAB29, and then also another one called RAB32. We call this site 1. And then there's another site that we call site 3 that binds RAB12. And then this is a feed-forward site. So when you have phosphorylated RABs on the membrane, this recruits more LRRK2 to that site. And then these RAB proteins are really critical for the recruitment of the RABs to the LRRK2 to the lysosomal membrane. So what we've done now is, through these structural studies we've done that have been involved both AlphaFold3, but also more recently with groups that do cryo-EM microscopy, we've been able to design mutations in each one of these sites that blocks, ablates these RAB binding sites. And then we've made knock-in mice, in which we have now mice, in which either the site 1, site 2, or site 3 are ablated. And then we can ask, how do each of these sites affect the activation of LRRK2 in response to specific signals? And then to cause lysosomal stress, we can use the various stresses. And I'm not going to go into the different stresses. They all cause lysosomal stress by different mechanisms, and they all lead to potent recruitment of LRRK2 to the lysosome and its activation. And then so I'm going to show you here that we've now mutated the site 3 in LRRK2. So this is the site that binds RAB12. And we made the knock-in mutation in LRRK2 that can't bind RAB12. And then we've taken the cells from the mice and we stimulated them with an agent called apilimod that this affects the ionic strength inside the lysosome and leads to the activation of LRRK2. So you can see in the wild type cells, you see a very big activation of LRRK2. And there's two different RABs you can measure. You can measure RAB12 phosphorylation or RAB10 phosphorylation. But interestingly, when you have the RAB12 homozygous mutation that can't bind the RAB12 that's through the site B, you block this activation, so it no longer occurs. So this is suggesting to us that this RAB12 site is really important, and we've come up with a potential pathway by which this might occur, that we're sort of involving many other components, in the lysosome that we're studying further in the lab at the moment. And I'll just skip along here in sort of time, and I'll go just the last 5 minutes or so. I'll tell you about another mutation that causes Parkinson's disease. This is in a protein called BPS35. It's a cargo-binding machinery that's called part of the retromer complex. And the way this works is it binds cargo, and it takes cargo from the endosomes to the plasma membrane, in the pathway known as the recycling pathway, or it takes cargo from the endosomes to the Golgi network in a pathway called the retrograde pathway. And the BPS35 binds cargo here, and there's one mutation called D620N. And this is a mutation that's found in people with Parkinson's disease. And it's also like LRH2, it's dominantly inherited through generations of family members. And what we found is that when we have this mutation in people as well as in mice, you have very high levels of the LRH2 kinase activity. There seems to be a physiological mutation that activates the LRH2 pathway and therefore causes Parkinson's disease. And we can see LRH2 has been recruited to the lysosomes, and you get increased phosphorylation of lab proteins. And we can measure this in humans. You can take patients who have BPS35 mutations, and you can measure the phosphorylated lab proteins in patients that have the BPS35 mutations. And then you can see you have elevated protein phosphorylation in the patient. So, and we see the same with mice. And I remember telling a patient who I met who had this mutation, and I showed them that result in my office. They came to see me. It was actually a Sunday, and now they were busy in the week time, so I was showing them the data, and I showed them the mouse experiments where we got the same experiment in the mouse. And I remember the patient being very fascinated by the fact that the mouse experiment gave the same result as with their blood. And let me just, so I think this is one of my last slides. This is where we are at the moment in dissecting the pathway. We know that this mutation causes lysosome dysfunction. It recruits LRH2 to the lysosomal membrane. You get phosphorylation of lab proteins. And then we've shown that this recruits this RILPAL1 to the phosphorylated lab protein. And then this causes a conformational change in the RILPAL1 that releases the C-terminal tail of the protein. And what's interesting, if you look at the conservation of all the residues, the last 13 amino acid residues of RILPAL1 are enormously conserved. And that's because this region actually binds to another lysosomal protein called TMEM55B. And this might be a master regulator of E3 ligases and other sort of biological responses. And we're sort of studying this biology in greater depth at the moment. And we've actually, with the collaborators, done some crystallography, and we can see how this C-terminal tail of RILPAL1 binds, and we can make mutations that disrupt this binding. We've actually made a knocking mouse, and we see we've related this binding domain so we can study this biology further. So this is my last slide. It's the pathway I've told you about, that when you have endolysosomal dysfunction, through pathways we still understand virtually nothing about. This leads to some sort of stress that activates a set of RAB proteins on the surface of organelles. These are some of the RAB proteins that become activated. They bind LRH2 in different ways, and they recruit LRH2 to the membranes of these organelles. Then the LRH2 phosphorylates a group of RAB GTPases, and this includes proteins that bind to the phosphorylated RAB proteins. And then on pathways, we're only starting to decipher. You get regulation of mitophagy, lysosomes, ciliogenesis, and this leads to eventually Parkinson's disease. So this is labs. I think we might have a little chapter. So in the RAB proteins, everyone knows that they're regulated by GEFs and GAPs. But what we're showing is that they're regulated by kinases such as LARC1, also the relative of LARC1 called LARC2. The relative of LARC2 called LARC1 also can phosphorylate proteins, and this is a sort of a new dimension in the way that the RAB proteins are regulated and controlled. And I put together some slides of the different people who worked in my lab over the last 20 years since we worked on LARC2, and it's been a very collaborative and interesting project to work on. And thank you for so many of you staying in this very warm, sunny afternoon in the outskirts of Abuja to listen to me waffle on about this topic. And I'm very happy to talk to you more about this. And thank you very much.
Another round of applause. Thank you, Professor Dario Alessi. Yes, I think so.
Sure, I can take questions, of course.
So we have one moment, please.
Let that be a standard question for this.
No, please. No, stay down.
So, do we have any?
Don't be shy, please.
You know, I'm sure they will ask me questions on this. Okay. I think I will kind of like start from possibly where you ended. When I saw that model which you showed, I saw BMP, bone morphogenesis protein.
No, it's called bis monoacyl glycerol. So it's a lipid. It's a lipid that's specific to the lysosomes. It's very interesting because there's a lot of hydrolases in the lysosome. And for the hydrolases to work, the substrates need to be solubilized. So there's small micelles of this specific lipid called BMP.
My other question is this: when you think I'll just ask to allow others to ask questions. The RAB proteins binding to the arm of the LAC2.
Yes.
Is there any conformational change that
it doesn't seem to be. It seems to be very rigid. I think it's recruiting. But I didn't say actually what we're trying to do. Everyone tells me this is crazy and will never work. We would like to build an inhibitor that would bind to that interface and stop the RAB from binding. But everyone tells me that won't work.
Okay. All right, my last question so that I can give you that chance. You talk about lysosomal stressors, right? And one of the inhibitors you show, likely inhibitors, actually happens to be chloroquine.
Yes.
And
for malaria treatment.
So my question is, have you guys looked at something of like antimicrobial peptides,
No, we haven't done. So chloroquine affects lysosomal pH, and therefore, I think it makes the lysosomes less functional. So the parasites need the lysosomes for their life cycle. So if you quench the lysosomes, you do harm to the person, obviously, but it's the balance between harming the person for a week and killing the malaria. It's a very good way to treat malaria, but it's yes. So in fact, many viruses are treated with these apilamod and things like that have been used for Ebola and other viruses because you disable the lysosomes for a week or so, and then you hope that you don't kill the person and you kill the pathogen before you kill the patient.
Any idea on stable peptides? Any idea on stable peptides? If looking at
it hasn't been tested. I don't think we've never tested it, but I don't think we would be happy to discuss that more.
All right. Okay. All right. Thank you.
I'm actually one of the students. I have been studying some kinases for the past 18 years. And in that course, I found out, or we reported for the first time, that some kinases, which we try to generalize, that to have those kinases may also be having phosphatase or dephosphorylation activities. So I think it's on what you have studied about the LAC2, we think this will hold for. Then my other question is about the individual. You know that kinases usually depend for most of the binding site of the individuals are often conserved across domains, not even many other proteins. So I don't know if you think this kinase inhibitor may be promiscuous and which may be having some downstream effects on other kinases. Then my last question is about the possibility, based on the studies, of if you think Parkinson's, you're targeting LAC2 and associated proteins, whether gene editing can be of help, gene editing technology can be of help.
Which technology?
Gene editing, such as CRISPR-Cas.
CRISPR-Cas?
Yeah, gene editing. Yeah.
Okay, great. So 3 questions. Your first question about protein phosphatases. So obviously, protein kinases, phosphorylation is so beautiful because it's reversible. You know, the phosphate comes on, it comes off. That's the beauty of the system. It's completely reversible, very easy. You know, you activate the kinase, inhibit the phosphatase, activate the phosphatase, inhibit the kinase. And that's the beauty of the system. So very few kinases have phosphatase domains, to my knowledge, within the same polypeptide. But every kinase that phosphorylates the substrate, there's phosphatases that remove it. So, and oftentimes, the phosphatases are much more complicated than the kinases. Often you have one kinase that puts the phosphate on, but you can have multiple phosphatases that take the phosphate off. So one of them is ppm1H that we've discovered. I didn't talk about it, but it's a specific phosphatase that has a RAB binding domain that's required to dephosphorylate the RAB proteins, and then there's maybe 3 of them in the human genome. Your second question about conservation of binding sites. Yes, across species, this is very, very important. Looking for conservation of sequences is the best tool we have. Even, just as important as AlphaFold, to look for critical regions in the protein. We use something called conserved motif. That's a very beautiful tool. It gives any residue of the protein a conservation score from 1 to 9, and you can some regions of the protein light up like Christmas trees, because they're conserved. And so yes, there's a lot of stuff there that's highly conserved. And then your third question about the specificity of protein kinase inhibitors. Yes, the MLI2 is quite selective, but like all kinase inhibitors, there'll always be 1 or 2 other kinases that can be affected. And we have 530 or so kinases in our body. To get one that's totally selective just for one kinase is a big ask. So it's possible that all kinase inhibitors will have off-target effects. So what's a good thing to do is, if you work with a kinase, is find 2 structurally different inhibitors. And if you get the same results with both inhibitors, and you also use a CRISPR knockout, then you can do that. And you also asked about the CRISPR, I think, as well. And I think people are considering doing CRISPR as a treatment, but it's very difficult because it's in the brain, and it's all over the brain, and it's not an easy thing to do at the moment, and to have all the potential off-target effects. But it will be a risky treatment to do CRISPR, I think.
My question is not to speaker, is to all of us here. We are here to do 3 things. One, we are here to do science. That's what just Professor Dario showed us. We are here to also do networking. So it's an opportunity for us to network among ourselves
and also with the president. The second one, and what's most important, there's a lot of opportunity for young scientists and students under IBMB. I told one of you will ask the president these questions. How do I apply for IBMB travel grant to attend conferences and workshops like this? How do I apply for... There's instructions? Oh, that's why this is left. Okay, thank you. So sorry.
Yes, but please do that. Please do the scheme and meeting people from other countries, America, Europe, Australia, Asia, South America. It's an amazing once-in-a-lifetime opportunity for you to meet young people that you haven't met before and talk to them, and they tell you about their problems. It might be similar to your problems, and it's you know, and then you might form lifelong friendships and have opportunities. And remember, life's about seizing opportunities, no matter how small that opportunity is. Look for it, identify it, and seize it. And then you'll start going up the ladder. And you know, many people don't seize the opportunities that come their way, and some do. And it's what makes the difference between success and failure.
Thank you, Gary. So my question is, yes, I have one question. Is there a possibility of setting kinases, phosphorylating RAS, under stress conditions?
Say that again,
So is there a possibility of other kinases?
Yes, no, there could be other kinases, yes. So, yes. So there's this LARC1 kinase that phosphorylates different RAS to LARC2, but we know at least one cellular situation when you knock out LARC2. If you treat with phospholesters instead of immune cells, you can induce phosphorylate. So we think there could be a LARC2 independent way of doing that, but we haven't studied that. So it's still open for research. That's the question. Thank you.
Thank you, Professor Messi, for that presentation and of course response. We will be going for the photo session. From there, we proceed to the poster presentations. Is that clear? Do you get me? From here now, we will proceed just out there, we will take the photos. Immediately after that, we will proceed to the other segment where the posters will be placed, and then poster presentation will proceed for about 30 minutes, after which we will go for the lunch.
But then at the end, you may only see a little bit of variation even within their sequences. So